Welcome to The Explainer. Today, we're putting together a practical career blueprint for every single electrical engineering student out there who's looking to really make their mark in the professional world.
So, if you're an electrical engineering student, this is the million-dollar question, isn't it? You're spending all this time mastering incredibly complex theories, but you're probably wondering, is my university curriculum actually preparing me for the job I really want?
And look, the stakes are unbelievably high. Just take India's semiconductor market. It's projected to just skyrocket to $64 billion by 2026. The opportunities, they're absolutely massive. But you know what that means? The competition is going to be fiercer than ever.
So, how do you actually bridge that gap between the classroom and a career? Well, that's exactly what this explainer is all about. We're going to start by really digging into that industry-academia gap. Then, we'll get you set up with the Modern Engineer's Toolkit. From there, we'll check out the hottest career paths, show you how to build your own personal blueprint, and finally, map out your path forward.
Okay, first things first, let's tackle the elephant in the room. This gap between the amazing theory you're learning and the practical skills that the industry is actually crying out for. It's all about understanding the difference between what happens in a lecture hall and what happens on the job. And this slide, it just lays it all out perfectly. On the left, you've got the why. You know, the super important theoretical foundations from your degree. But over on the right is the how. What recruiters are really looking for. They want to see hands-on project experience, real problem-solving skills, and yeah, knowing your way around tools like HDL programming. Your theory is the foundation, for sure, but these practical skills, that's what's going to get you hired.
So, how do you start bridging this gap? You begin by learning to speak the language of the industry. And today, that language is definitely software. So let's take a look at the essential tools you absolutely need in your toolkit.
Now, this isn't just some random list. Think of this as your professional toolkit. Getting good at industry-standard software is pretty much non-negotiable. I'm talking about using MATLAB to model complex algorithms, or using ETAP to simulate an entire high-voltage power grid, or maybe Keil UVision to program the microcontrollers that are at the heart of all those embedded systems. These are the tools you'll be using day in and day out. Okay, so once you have the right tools in your belt, you can start setting your sights on some of the most exciting, most future-proof career paths in the entire industry. I mean, these are the fields where innovation is just happening at lightning speed, covering everything from low-voltage electronics all the way up to massive high-voltage power systems. Just look at these 5 domains. They are all experiencing explosive growth. You've got VLSI, that's very large-scale integration, which is basically the art of designing the microchips that power, well, everything. Then there's embedded systems and the Internet of Things, or IoT, which is all about making devices smart and connected, a huge field in low-voltage design. And then you jump to power systems and smart grids, where you're dealing with medium and high voltage to manage how power is generated and sent everywhere. Automation is completely changing manufacturing plants, and of course, EV technology is turning the whole transportation industry on its head. All right, we've seen all the exciting places you can go. Now let's actually build the map to get you there. This is all about being strategic, being proactive about building the right skills while you are still in university. So here it is, your action plan. Step 1, strengthen those core fundamentals. They really do matter. 2, go after specialized training. A lot of manufacturers like Schneider Electric, Siemens, or ABB have free training modules online. Go find them. 3, master the software we talked about. But number 4, and this is absolutely crucial, is to get hands-on. Start a simple routine. Once a week, just download and read a real product datasheet. Learn how to read protection selectivity charts, study wiring diagrams, and actually understand what a transformer nameplate is telling you. This kind of practical knowledge is pure gold.
I get it. With so many cool options, trying to pick a specialization can feel, well, a little overwhelming. But honestly, the best way to focus your efforts is to connect these career paths to what you genuinely enjoy doing.
And this table here illustrates it beautifully. Just ask yourself some simple questions. Do you love deep theory and research? A path in academia might be perfect for you. Do you enjoy design, doing calculations, bringing whole systems to life on paper? Then you should look into design engineering for things like building services or substations. Or maybe you prefer hands-on work with actual equipment. Then a career in a manufacturing plant or in process control is definitely your calling. And if the just massive scale of large power grids gets you excited, well, generation and transmission is where you belong. Let your passion be your compass.
So let's wrap this up by looking at the big picture. This journey isn't just about passing exams or even just about landing your first job. It's about a total transformation from being a student into becoming an innovator who's actually going to shape the future of technology.
This quote really says it all. The industry needs creative problem solvers who can think at a system level. Your academic journey is the critical first step, but it's your commitment to practical skills and to just continuous learning that's going to define your entire career.
And so we'll leave you with this final thought, this challenge. Don't wait for graduation. Don't wait around for the perfect opportunity to fall into your lap. Pick a path that genuinely excites you, find a data sheet for a real-world component, and start learning how it actually works. Today. So what are you going to build first?
Hey, thanks so much for watching. We really hope this blueprint helps you on your journey. If you found it valuable, please share it with a friend or a colleague who might need it too. And for more explainers on all kinds of topics in electrical engineering, be sure to like, share, and subscribe to the channel.